Hi students, today I want to discuss about the continuation part of this chapter, Hess law. This law states that the heat changes during the chemical reaction is a constant, whether reaction takes place in a single steps or number of steps. Okay, this is known as statement of the Hess law. When a chemical reaction, in a chemical reaction, during the chemical reaction some amount of heat liberated or absorbed. It remains constant, say when this same reaction maybe takes place in 2 or more steps. Okay, so statement of this law is, Hess law state that the enthalpy change or change in enthalpy, okay, enthalpy change during the chemical reaction, during the chemical reaction remains constant, whether it takes place in single steps or number of steps, whether it takes place in single steps or number of steps, Let us consider an example for this reactions. Example, carbon react with oxygen, they form CO2, carbon dioxide. Delta H value for this reaction minus 393.5 kilojoules. So physical states of this one solid, this is a gas. Actually, this reaction takes place in single steps. How much heat get liberated? 393.5 kilojoules of heat gets liberated. Now this reaction now suppose takes place in 2 steps. Means carbon may react with oxygen, they form carbon monoxide. Suppose so carbon monoxide. So we'll balance the equation, put here half. So solid, physical state solid, this is a gas, So delta H value is equal to minus 110.5 kilojoules. Next steps is carbon monoxide react with the oxygen, they form CO2, carbon dioxide. So we'll balance the equation here half. So this is a gas, it is also gas. So delta H value is equal to minus 283.0 kilojoules. So this is taken as equation 1, this is taken as equation 2. Now we can add these two equations. Actually this is takes place in a 1 step. So this we can add these two equations. Equation 1 plus equation 2. Equation 1 plus equation 2 implies that. So CO get cancelled. Half O2, 1 O2. So C physical state, half O2, 1 O2 gas. They forms CO2. This is a gas. So delta H value is equal to same. You can add these two value. So 5 point here 3. This is a 9, this is a 3, minus value, minus 93.5 kilojoules. Means, so formation of carbon dioxide takes place in single steps. How much heat get liberated? 393.5 kilojoules heat get liberated. Suppose same reaction takes place in 2 steps. How much heat get liberated? Same 393.5 kilojoules of heat takes place. So means heat changes during the chemical reaction remains constant, whether it takes place in a single steps or number of steps. This is known as a Hess law. So that's why the statement of Hess law is enthalpy change during the chemical reaction remains constant, whether it takes place in a single steps or number of steps. So this is heat changes total remains constant. It's a statement of the Hess law. Okay, next problems. Calculate the heat of formation of ethyl alcohol from the following data. So first formation of carbon dioxide. formation of water and formation of conversion of ethyl alcohol is given. Ethyl alcohol during the combustion they form say carbon dioxide plus water. This is a combustion. These two are the formation carbon dioxide, formation of water. Question is calculate the rate of formation of ethyl alcohol. First of all I write a formation of ethyl alcohol, that means required equations. Here first required equation, which equation is required here? Required equation, what is the required equation? Formation of ethyl alcohol means C2H5OH, ethyl alcohol. What are the elements of this one? Carbon, hydrogen, oxygen. So while balance equations, 2 carbon, 5 plus 6, 3, oxygen half. Okay, this is a solid, gas, liquid. So you have to find out what is the change in enthalpy. You have to find out here during the formation from these 3 data. So what are data is given here? The given data, C plus O2, they form CO2. So delta H value is minus 393.5 kilojoules. So this is a solid, this is a gas, this is a gas. Second equation is hydrogen gas plus half O2. This is also gas. They form H2O. This is a liquid state. So delta H value is equal to minus 285.8 kilojoules. Third one is C2H5OH, ethyl alcohol plus 3 mole of O2. They form 2CO2 plus 3H2O. It's a given. So delta H value is equal to minus 1367 kilojoules. Okay, so this is a liquid state, this is a gas, here also gas, here liquid. So now I can name it as this equation 1, this is taken as equation 2, this is taken as equation 3. Means from these 3 equations you have to simplify this one. So what are the arrangements should be done? Here see, first of all, we have to see the required equation. So this is the required equation. In the required equation, how many mole of carbons are there? 2 mole of carbons are there. But here in this equation, how many mole of carbon? 1. That's why this equation multiplied by 2. Why is it multiplied by 2 here for this equation? Here 2 mole of carbon. Next see, how many mole of hydrogens are there? 3 mole of hydrogen. Here how many mole of hydrogen? 1 mole. Now that's why this equation multiplied by 3. And one more point, see, ethyl alcohol present which side now? Product side. But here present in the reactant side. That's why this equation gets reversed it. So these are the 3 changes we done. Then you get a final equation. First equation multiplied by 2, second equation multiplied by 3, third equation is reverse. I can done these 3 changes. So I can here first equation is multiplied by 2. Okay, from the given data. So first equation multiplied by 2. So equation 1 multiplied by 2. So 2 mole of carbon plus 2 mole of oxygen gas, they form 2 mole of carbon dioxide gas. Their data also multiplied by 2. Okay, multiplied by 2. So 2 into 5, 0, 10, 2 into 3, 6, 7, 2 into 9, 18, 2 into 3, 6, 7. Okay, 2 into 3, 6, 7. Here is correct. Multiplied by 2. So minus value. This is a kilojoules. Second equation. What is second equation multiplied by 3? Equation 2 multiplied by 3. So 3H2O gas plus 3 by 2 O2 gas gives 3H2O. Here gas, so liquid states here. So they are also multiplied by how much? 3. So 3 into 8, 24. Okay, 3 into 5, 15, 16, 17. 3 into 8, 24, 25. 3 into 2, 6, 7, 8. This is a minus kilojoules. Okay. Next, what about this one? Third equation reverse. Equation 3. Equation 3 reverse. Reverse the third equations. So I reverse the equation. 2CO2 plus 3H2O. Okay, this is a gas. It is a liquid. Gives okay C2H5OH liquid plus 3O2 gas. Delta H value is equal to it, because during the reversing we know that negative symbol changes to positive. So plus 1367 kilojoules. Okay, now you give new numbering for this equation. Give the new numbering. So this is taken as equation 4. This is a 5. This is a 6. Give the new numbering for this one. So next, just add here equation 4 plus equation 5 plus equation 6. Do it. Equation 6. So you can add all this. Each terms cancelled. Yes, say 2CO2 cancelled with the 2CO2. Correct. Next 3H2O cancelled with 3H2O. Okay, oxygen, see this side, because see, if suppose same types of reactant or elements are present in the opposite side, means reactant or product, they will be cancelled. But same side we can add it. Here see oxygen, here 2 mole, here 3 by 2 mole. Then here 3 by 2. First you can add it, then subtract it. So here 2 plus O2, I can say O2, 2 plus 3 by 2, here 2, so 2 to 4, 7 by 2. Here 3 is there, I bring this side, it become minus. So 7 by 2 minus 3. So here 2 LCM, 7 minus 6 equal to 1 by 2, get it. So how many mole of oxygen get it? 1 by 2. Okay, write the remaining terms now. 2C is remaining plus 3H2O solid state, 3H2O gas. Okay, oxygen how much remaining here? Half O2. Half O2 gas gives C2H5 in the product side. What's remaining? C2H5 liquid state. Correct? The same equation, get it. Required equation. This is a required equation. Here also get required equation. Then you have to simplify delta H value. Means this is a minus, this is a minus. We can add these two. Then it is added to this one. Okay, if you simplify, finally answer is if you simplify minus 277.4 kilojoules, you get it. Correct it? Now these two are added, then it is added to here. This minus added, then added. You get this. So this is a enthalpy of H1 formation of ethyl alcohol from this for this problem part. Okay, this is a very important problem for the theory exam. They ask for the 4 marks. Sometime they directly give the data. This data will be given. They ask to find out some formation or conversion. Otherwise, some sentence will be given. They ask to find out. Okay. So total this problem is important for the theory exams. Okay, here one more problems. Actually, this problem and previous problem actually same, but previous problem actually equation is given, but here equation is not given. Instead of equation, they given a sentence. Okay, so that's why first you frame the equation, then you have to simplify it. So here problem is calculate the enthalpy of formation of the methane. Question: calculate the enthalpy of formation of methane. So first I write the required equation directly here. So solution for this one. So required equation. So what is equations they ask here? Formations of the methane. So CH4, methane, physical state gas. What are the elements of methane? Carbon and hydrogens. So I'll balance equation 2. So solid, this is a gas. Okay. So during this, how much heat gets liberated? This is the questions here. Okay. So then what are the equations that are given here? Point are given. Given that the enthalpy of formation of carbon dioxide in water, formation of carbon dioxide or given data. Here given data. Okay. What are data given here? Formation of carbon dioxide. CO2 and formation of water H2O. So what is formation? What are the elements of carbon dioxide? Carbon plus oxygen. What are the elements of the water? Hydrogen plus oxygen. So we'll balance equation half. This is a solid, this is a gas, this is a gas, this is a gas, it is also gas, it is also liquid. So what is the delta H value? Minus 393.5 kilojoules. This value is minus 285. Okay, 285.8 kilojoules. This is given. Next, one more data. Enthalpy of combustion of methane is given. Combustions of methane. CH4. This is a gas. Combustion O2. Gas. What is the product here? CO2 plus H2O. So this is a gas. This is a liquid state. So I have to balance here. Hydrogen 2 now. Here put it 2. Oxygen 2 plus 2 4. Here 2. So delta H value is equal to minus 890 kilojoules is given. So these are data is given. These three equations. Now we can name it as, this equation is named as 1. This is named as a 2. This is named as a 3. Okay. Totally you want to obtain this equation from these three data. Tell me what are the arrangements to be done to get a required equation from these three data. Okay. See, first of all, you can see the carbon. How many mole of carbon will be there here? 1 mole of carbon. But here also 1 mole. That's why equation 1 as it is, no change. Hydrogen, how many mole of hydrogen? 2 mole. But here 1 mole. That's why this equation multiplied by 2. Second equation multiplied by 2. Next, methane is a present which is side, product side. But here reactant side. That's the third equation gets reversed. These are the changes you done here. Okay. So I can write change done. What are the changes here? So equation 1 as it is. Equation 1 no change. As it is. As it is. There is no change in the first equations. So I can write as it is. So carbon plus O2. They form CO2. This is a gas. Delta H value minus 393.5 kilojoules. So, and this equation I named as a 1 as it, no changes. No, this can write equation 1 is the second equation multiplied by 2. 2 mole of H2O plus O2. This is a gas. They form H2O. This is a liquids. Here this is a gas. So delta H value is equal multiplied by 2. So multiplied by 2. So 2 into 6. 2 into 6. 8. 2 into 8 16. 2 into 5 10 11. 2 into 8 16. 16 17. 2 into 2 4 5 minus kilojoules. So third equation, what is the third equation? Third equation gets reversed. So third equation reverse. So 2H2O plus O2, they form CH4 plus 2O2. So here liquid, gas, gas, gas. So delta H value reverse now. So plus 890 kilojoules reverse. So now this equation is saying, you give the new numbering for this one 4. This equation named as a 5. So now afterwards we can add all the equations. Means equation 1 plus equation 4 plus equation 5. We can add all this equation. So which term get cancelled here? So here CO2 cancelled with the CO2. H2O here this equation, how equation multiplied by how much? 2 now here 2. I forget it here. See 2H2O. This one 2H2O. Yes. So 2H2O cancelled with the 2H2. O2. Yes. 1O2 1O2 2O2. 2O2 cancelled with the 2O2. O2 O2 2O2 cancelled. So then what is remaining here? C, carbon, solid state, plus 2H2O. This is a gaseous state. So what is the product here? CH4, methane is formed. This is a gas. Okay, delta H value is equal to same thing. First these two are the negative. Now we can add it, then it is added to this one. Okay, these two are added here. So about answer is here minus 81.6 something will be getting. This is approximate answer, not per proper answer. This is approximate answers to solve this one. So this is a way of solving the problems. Okay, these types of problems also important for the theory exams. Here on problems, same types. Calculate the enthalpy of combustion of carbon disulfide given. Calculate enthalpy of formation of carbon disulfide, sulfur dioxide given. Calculation of enthalpy of formation of the carbon disulfide. Methods the same. First you write required equations. Okay, solution for this one. First you write a required equation. So required equation. So formation of the carbon disulfide CS2, it's a liquid state. What are the elements of this one? Carbon plus sulfur, it's a gas. It is also solid. So 2. So during this, how much heat gets liberated? You have to find out. So what are data given here? Given data. Okay, given data. See, first combustion of a carbon disulfide given. Carbon disulfide combustion O2. What is the product from carbon disulfide? Carbon and sulfur is there. Now that's why they form say CO2 plus sulfur dioxide is formed. Okay, so while balance equation 2, here 2, 4, here it think 3 now, correct? 2 plus 4, 6. So gas, here delta H value is equal to minus 1071 kilojoules. Next, formation of carbon dioxide and sulfur dioxide. Formation of carbon dioxide, formation of sulfur dioxide. What are the elements of carbon disulfide? Carbon plus oxygens. So this is a solid, this is a gas, this is a gas. Sulfur dioxide, sulfur plus oxygen. This is a, I can take gas, sulfur taken gas, here also gas, sulfur dioxide gas. So delta H value is equal to formation carbon dioxide minus 393.5 kilojoules. This one is delta H value minus 297 kilojoules. This is the values are given. So now you can modify these three equations by seeing the required equation. This is named as 1, named as a 2, named as a 3. So what are the changes we done? See, first carbon, here also carbon, 1 mole, no changes. So equation 2, no changes. Next sulfur, 2 mole, here 1 mole, this equation multiplied by 2. Third, carbon disulfide product side, here reactant side, this is the reverse. This is the reverse, no change, multiplied by 2. Okay, I done here. So equation 1 is the reverse. I can write reverse, CO2 plus 2SO2 gives CS2 plus 3O2. So delta H value also changes plus 1071 kilojoules. Equation 2 as it is, no change. C plus O2, they form CO2. So this is a gas, it is also gas, liquid gas. This is a solid gas. Delta H value, so 393.5. But whatever this equation multiplied by 2, because 2 sulfur now. So 2S plus 2O2 gas, they form 2SO2. This is a gas. Delta H multiplied by 2. So here multiply by 2. 2 into 7, 14. 2 into 9, 18, 19, 2 into 2, 4, 5. So minus, this is a kilojoules. Okay. Now add this equation. This is named as equation 4. This is named as equation 2, no changes. This is equation named as a 5. So equation 4 plus equation 2 plus equation 5 implies that. So which term we get cancelled here? So here cancelling terms is see, so carbon disulfide here it be there now. So oxygen, so carbon dioxide cancelled with the carbon dioxide. 2SO2 cancelled with the 2SO2. Oxygen 3O2. Here 2O2 plus 3O2. This is also cancelled. 3O2 cancelled with the 3O2. So what is the remaining terms here? Carbon solid plus 2S gas. They form product side CS2 liquid. Delta H value find. How to find out delta H value? So you have to first you have to add the negative symbol. Next you can be simplify this one. These two add. So answer is minus 83.5 kilojoules. This is the final answer, we get it. Okay. This is a formation of which one? Carbon disulfide. This problem also important. Okay, next concept is enthalpy of the phase transformations. So first under this one, enthalpy of fusions. What is the enthalpy of fusions? You know terms. So fusion means solid to liquid state is called fusion. Vaporization, liquid to gas. Sublimation, solid to gas. Okay, different terms are used. So first I discuss about the enthalpy of fusion. So let us consider ice. It is exist as a solid. Now I want to change it to liquid state. For this process, plus 60 kilojoules amount of energy is required. Means heat get absorbed. This is called enthalpy of fusion. So enthalpy of fusion can be defined as a change in enthalpy that occurs when 1 mole of substance changes from the solid state to liquid state at its melting point. It's called enthalpy of a fusion. So it's defined as it is the change in enthalpy. Change in enthalpy that occurs when 1 mole of substance changes from solid state to liquid state at their melting point. It's called enthalpy of the fusions under standard conditions. Okay. So second term is under the phase transformation, enthalpy of vaporization. Enthalpy of vaporization. Okay, what is enthalpy of vaporization? So vaporization, liquid changes to gaseous states. Your vapor state is called enthalpy of vaporization. Suppose water physical state is now liquid, changes to gaseous state. For this purposes, around 60.0 kilojoules of energy gets required as positive. This is called enthalpy of vaporization. So it is defined as a change in enthalpy that occurs when 1 mole of substance changes from the liquid state to gaseous state at boiling point. It's called enthalpy of vaporization. So it is the change in enthalpy. Change in enthalpy that occurs when 1 mole of substance changes from liquid state to gaseous state at their boiling point is called enthalpy of vaporization. Okay, next term, phase transformation. Enthalpy of sublimation. Sublimation. This is also including the enthalpy of including the phase transformations. So here, suppose iodine, solid state, directly changes to iodine, gaseous state. During this process, around 62 kilojoules of heat gets absorbed. This is called enthalpy of sublimation. So what is enthalpy of sublimation? Change in enthalpy that occurs when 1 mole of substance changes from the solid state to its liquid state below their melting point is called a enthalpy of sublimation. So it's defined as the change in enthalpy. Change in enthalpy that occurs when 1 mole of substance changes from solid, or is 1 mole of substance converted from the solid state, 1 mole of substance changes from solid state into gaseous state below their boiling point is called enthalpy of sublimations. So these are the 3 processes that comes under the enthalpy of a phase transformation. So fusions, vaporization and sublimations. Okay, next term is enthalpy atomization. So enthalpy of atomization means the molecule converted into atoms is called atomization. Atom, the term itself indicate molecule from its standard state converted into atoms is called enthalpy atomization. For example, hydrogen gas, exists a gaseous state, changes to atoms 2H, but should be the gaseous state. That is called enthalpy of atomization. Here 436 kilojoules of energy gets liberated. It is called enthalpy atomization. So it is defined as a change in enthalpy that occurs when 1 mole of substance present in the standard state, okay, standard gaseous state, is converted into constituent atoms in the gaseous state. This is which is the constituent atoms? Hydrogen, or chlorine molecules converted into chlorine atom, nitrogen molecule converted into nitrogen atom. That's called enthalpy of atomization. So it's defined as the change in enthalpy that occurs when 1 mole of substance changes from its standard state into constituent atoms in gaseous state. Is known as enthalpy of atomizations. Okay, so this is here hydrogen molecule is converted into hydrogen atom. This is called enthalpy atomization. Next term is bond enthalpy. Okay, bond enthalpy. Actually, how much amount of energy required to break the covalent bond present between the atom and convert it into its constituent atoms in its gaseous state is called bond enthalpy. But in this case, first I can define for a diatomic molecules. Okay, one simple example, consider hydrogen molecule, H2 molecule. It's converted into hydrogen atoms. So here some amount of it means 436 kilojoules of amount of energy required is called bond enthalpy or bond dissociation enthalpy. Bond dissociation enthalpy. Okay, both meaning will be the same. So what is the bond dissociation enthalpy? Amount of energy required to break the covalent bond present between the atom, okay, from its standard state into its constituent atom in the gaseous state is called a bond dissociation enthalpy. So it is the amount of energy required, required to break the covalent bond, okay, covalent bond present between the atoms in a standard state into constituent atoms in the gaseous state. But the final atom must be present in the gaseous state. That's the condition. This is called bond. Here, actually between the two hydrogen atoms, there is a covalent bond. How much amount of energy required to break the covalent bond? That is called bond dissociation enthalpy in the case of diatomic molecule. Then I go for the polyatomic molecule. Second term is a polyatomic molecule. Polyatomic molecules means there is more than two covalent bonds are present between the atom, between the atom in case of the molecules. For example, methane. We know that in methane there is a 4 CH bond is present. Okay, take as example some methane, CH4, methane. Actually in methane there are 4 CH bond is present. 4 CH bond. Now, how much energy required to break the one covalent bond present between the atom in the molecule, polyatomic molecule, and convert into constituent gaseous atom is called actually bond dissociation enthalpy in the case of the polyatomic molecule. Actually, when methane in a gaseous state, it's a cleavage. They forms a carbon gaseous state, hydrogen, 4 hydrogen. It's a gaseous state. Actually, amount of energy required is plus 1665 kilojoules of amount of energy required. This is a cleavage of how many CH bond? 4 CH bond. Okay, but how much amount of energy required to break the one CH bond? Therefore, the CH bond in methane CH4 is equal to, we know that to break the 4 CH bond, this much amount of energy required. To break one CH bond, 1665 divided by 4, this much amount of energy required. Because for one bond this much, for 4 CH bond how much? So answer is 4 to 25. 25 means 6.5. This much amount of energy required to break the one CH bond. So this average energy is called bond dissociation enthalpy of the polyatomic molecules. Therefore, the bond dissociation enthalpy of the polyatomic molecule can be defined as it is the average energy. It is average energy required. Average energy required to break the covalent bond present between the atoms in polyatomic molecule, in the polyatomic molecule, and converted converted into constituent gaseous atom is known as a bond dissociation enthalpy in the case of polyatomic molecules. And what is the relation between the bond dissociation enthalpy and enthalpy of the reaction? Here, the relation between the enthalpy of the reaction, and bond dissociation enthalpy. Enthalpy of the reaction and bond dissociation enthalpy can be expressed as enthalpy of the reaction during the chemical reaction is equal to summation of bond dissociation enthalpy of reactants minus summation of bond dissociation enthalpy of products. Okay, this is the relation between the change in enthalpy and bond dissociation enthalpy. Change in enthalpy is equal to summation of bond dissociation enthalpy of the reactant minus summation of bond dissociation enthalpy of the product. This the formula gives the relation between the enthalpy and the bond dissociation's enthalpy. Okay, next on problems here. Calculate the enthalpy change for the combustions of the propane, given that bond dissociation enthalpy of the various bonds are given here. First, calculate enthalpy change for the combustions of the propane. You know propane formula C3H8 propane. So propane during the combustion, what's the product? CO2 carbon dioxide plus H2 is formed. The question is during this process how much heat gets liberated. It's called enthalpy of combustion. So first balance the equation. Here 3, here 8, that's why here 4. What's number of oxygen? 3 into 2, 6. 6 plus 4, 10. That's why here it becomes 5. I can write the structure of this one. Here carbon, there are 3 carbon atoms are there. Next hydrogen, 1, 2, 3. These are the hydrogen. Totally 8 hydrogen atoms are present here. Here we can observe CC bond as well as the CH bond. Plus 5 O double bond O. Okay, gives 3 CO2, 3 outside O double bond C double bond O plus 4 water molecule HOH. This is structure. So now you know that how to find out change in enthalpy. Change in enthalpy is equal to summation of bond dissociation enthalpy of a reactants minus summation of bond dissociation enthalpy of products. Okay, products. This is the formula. So reactant minus product. This is reactant, this is a product. So now see in this case what are the types of bonds are present in the reactant? CH bond as well as the CC bond. CH bond. How many CH bond? So CH bond here 1, 2, 3, 4, 5, 6, 7, 8 CH bond. That's why 8 into CH bond. CH bond is a given. CH bond and dissociation enthalpy given 8 CH bond plus how many CC bond? 2 CC bond. Okay, plus 5 OO bond. 5 OO bond, oxygen bond. These are the bonds that comes under which one? Reactant. Minus bond dissociation enthalpy product. So product, what are the bonds? CO bond. How many CO bond? Here 2 into 3, 6. So 6 C double bond O. Correct? 6 into this CO bond plus OH bond. OH, how many OH bond? 2. 2 into 4, 8 plus 8 into OH bond. So this is the formula, reactant minus product. Now I substitute all the values. So delta H value is equal to 8 into CH bond value is given. What's the CH bond here? 414 plus 2 into CC bond. So CC bond is given. What's the CC bond? 347. Okay, 3 CC bond plus 5 into OO bond, 498. Okay, next minus bond dissociation enthalpy product 6 into C double bond O given 741. Okay, next plus 8 into OH bond. How many OH bonds here? How much? What's the value of this one? 464. Okay, then you simplify here. Delta H value simplified. Okay, if you simplify the CH bond during this one, answer is minus 1662.4 kilojoules. Answer will be get it. So this is actually enthalpy of combustion during the combustions of the methane. Methane during the combustion, how much heat get liberated? 1662.4 kilojoules of heat gets liberated. That is called enthalpy of the combustions. Okay, this is way of solving the problem, but this formula is, remember, delta H is equal to summation of the bond dissociation enthalpy of reactant minus summation of the bond dissociation enthalpy of the product. This formula is important.